Hello and welcome to this Automotive Ethernet technology video. Today we want to show you how to measure an Automotive Ethernet multi-gigabit cable, and therefore I have with me Mr. Bert Bergner, who is Senior Principal Engineer at TE Connectivity. Welcome, Bert.
Hello, Jörn. Thank you very much for the introduction.
So today we have brought our ZNB20 vector network analyzer, and Bert, you have brought a new kind of cable. Can you explain what you have with you?
Yes, this is an assembly with an shielded twisted pair cable, or in short STP cable, and we have attached our TE Connectivity BEAMnet connector to the cable segments. This miniaturized connector system is specifically developed for data transmission on balanced pair cable at frequencies up to 10 or even 15 gigahertz. So we have here 5 cable segments, and the connectors between the segments are called inline connectors. At the end of this cable assembly, we have also 2 of these BEAMnet connectors. In a real application, these connectors would be plugged into the electronic control units in a car. Here we want to measure the performance of our cable assemblies, and therefore we need to connect it to our network analyzer. For this reason, we have these 2 test fixtures. Yeah, and now I think we are ready for the measurement and to see if we meet the requirements.
When we are talking about the requirements, you are chairman of the OPEN Alliance TC9 technical committee, and can you explain what this working group is doing?
Yeah, the performance of the complete link segment is defined by the Automotive Ethernet standard for 2.5, 5 and 10 gigabit data transmission over a single balanced pair cable. Link segment, this is the IEEE term for the complete cable assembly as we have it here on our table. The standard defines the required performance, but not the components, which are the connectors and the bare cable. And this is exactly what we are doing in TC9. We are specifying the minimum requirements for the cables, for the connectors, to make sure that components from different vendors can work together in one systems. And in addition, we also take care about the measurement methodology to make sure that the results are comparable.
Okay, so in the end you make it easier to understand what the specification is saying for the user, right?
Yes.
Okay, great. So should we now have a look at the results?
Yeah. So here we have the SDD11 parameter. And this parameter gives us the ratio between the transmitted signal and the reflected signal. The positive value with a positive sign here is also known as return loss. And as we can see, we have a comfortable margin to our limit, despite the 4 inline connectors here in our cable assembly. The second parameter in the bottom here, this is SDD21. And this chart tells us that we also meet the insertion loss requirements. And finally, we have also the propagation delay of the signals, which is also well within the limits.
Okay, thank you very much, Bert. It was nice to have you here and that you explained the work of the TC9 working group of the Automotive Ethernet Open Alliance, and that you showed your new multi-gigabit Ethernet cable to us. Thank you very much. That was nice to have you here.
You're welcome. It was a pleasure.
For this measurement, we were using the ZNB vector network analyzer up to 20 gigahertz. As well, we used phase-stable cables and an automatic calibration unit to perform an automatic calibration. As well, the K2 time domain option is very useful in that context, because typically you need to measure impedance over time for the Automotive Ethernet specifications. And as well, de-embedding is very useful, because then with the use of a 2x through coupon, you can de-embed the influence of the fixtures that you need to connect the coaxial cables of the vector network analyzer to the Automotive Ethernet connector. And with the help of this de-embedding, you can calculate out the influence of these fixtures to have the result without this influence and only show the result of the cable test. If you want to know more about our solutions, visit our Automotive Ethernet Solutions webpage, where you can find a lot of useful information and other nice videos. So thank you for watching this video. See you next time and goodbye.